Okay, we are live with Just a Walking Fish so far, and myself, Speed of Sound. And you want to introduce yourself again? No, you haven't been on here, so you need to introduce.
This is my second time being on, but
yeah, but I couldn't find your video.
like my channel. What do you mean?
No, I couldn't find the video that we did together. Did we talk privately, or did we do it
No,
online?
I was on with Immutable one time.
Oh, okay. You were on with Immutable. Okay.
Yeah.
So hell, then your old stuff. We know you.
Yeah.
So
At this point, basically ancient for this channel.
yeah. So we're going through a video with that Sal Cordova did on two different channels. He did the same lecture. The first one was on with John Maddox, and the second one was on Standing for Truth's channel. And we're going to kind of go through the second one first because it's a little more condensed, and then maybe hit the second one. And I just want to get into an intro here. Basically, Sal is constructing a really good straw man argument against evolution. And I mean, a straw man argument, and they often misuse this term themselves. It's a misrepresentation of an actual argument, and it's constructed so that you can destroy it because a cartoon is easy to destroy. And the straw man that he constructs is that somehow a pop-gen equation from 90 years ago is the only evidence, or is our evidence for evolution, and that we teach this to students and they just accept it without questioning it. Nobody questions it. It's called the fundamental theorem of evolution for some reason. And I got a news flash for him. Things evolve all by themselves without the equations that we use to model and explore various parts of evolutionary structure. This equation is how we model it and how we figure out something about a particular part of, like, for instance, how alleles behave in an ideal situation, so we can understand the mathematics. The thing about this statistical mathematics is that when you actually work it out, it often surprises you. It's not intuitive. So that's why we do this, and we have these idealized equations, and that's all that Fisher's theorem was. Let's see. An equation failing or not explaining complexity does not mean that evolution is false. Scientists saying, I don't know, or I got it wrong and have to revise is not proof of God. Sal seems to want fitness to mean the complexity of life's many forms and life's wily methods of staying alive. He wants to redefine fitness for some reason. I think so it fits into genetic entropy. The issue of complexification in evolution has nothing to do with the models that are used to measure rates of increases of alleles in populations. Nothing to do with population genetics. Now I want to go back out here to the bigger picture. Creationists have a new song. They claim to be doing real science, claiming that all other sciences are not doing real science. And the entire project is to find papers and research, pick out the parts that give them orgasms, mostly cherry-pick quotes, and then claim they found big problems for evolution. They do not give a damn about advancing our knowledge. They only talk about advances as they pertain to stopping evolution research and abiogenesis research in its tracks. So they cherry-pick science to promote their worldviews. If we all became yaks tomorrow, they would have nothing further to say, nothing to research. And so I call this method chicken picking science. Chicken picking science. So I'll have to put that in the chat because I think that's kind of special.
Chicken picking?
Chicken picking science. Yeah, it's pretty cool. And of course, my Mac just went nuts on me. Let's see. Let's see if I put a comment. Anyway, I think it's a good term for what they do. This cherry. I mean, they cherry pick all these little points, like Nephilim Freel have all these rocks that he found that, don't fit it, or fossils that don't fit into the scheme of things. And that's all they ever talk about. They never talk about the overall theories. And I think that is where they really fail, and that's why they aren't doing science. They have nothing to do with science. Standing for Truth is here. Hi there. Anyway, chicken picking science. So we have a video here. The first one is done on, and I will link everything, but it's gonna take me a while to put together all the links. I have, I think, 30 papers downloaded based on what Sal says here and how, what he comes up with. And I have a bunch of links. Going through the entire video would take way too long, so I thought I'd just go to the highlights. And this is the one that's on Standing for Truth's channel. So should I roll it?
Yeah.
Sal Cordova is here, and he's thanking all his anti-fans. I think I probably have 3 people watching my channel, you know. Yeah, 3. Exactly 3. Sal, Standing for Truth, and I don't know who the other guy is. Let's see. Where are we?
And that was years of hard work to come up with this proof, and it was devastating for Darwinian evolution. But there's some backstories to that. I'm going to cover what happened was because editors were approaching Bill Basner and John Sanford for follow-on work. I got recruited to be doing some of the follow-on work because I do have a mathematical background. I'm really not a biologist by training. I'm only a recent biologist, quote unquote. That's the theorem right there. I'm going to cover the simplified version, but please don't run away because the fun stuff is not going to be in the math. Now, I want you to see this. This is a very interesting book. It's called Survival of the Sickest. Survival of the Sickest. Does that sound familiar, like Survival of the Fittest? Well, this so-called medical maverick, Dr. Sharon Moalem, he said, the subtitle's not, here it is. A medical maverick discovers why we need disease. Why we need disease. Now, the reason that's, if that sounds kind of bizarre, it is because it is bizarre. There's a problem with Darwinian evolution in that maybe 90% of...
Okay. So that book, Survival of the Sickest?
Yep.
Just happen to have a copy right here. And it's about... basically talks about how intertwined all life is and how germs and disease and everything often have fairly surprising effects on us. A lot of germs and viruses are good for us, and a lot of genetic diseases like sickle cell anemia turn out to help us survive in certain circumstances, and some things that are diseases end up being not so disease when you change the environment. So that's kind of what that's about. And it's sort of, I'm not sure if Sal read the book or not. It's kind of a nice little piece. It's an interesting book. Doesn't really say what I think Sal wants it to say, but and then he talks about this 90%, and let's see what he says here.
The mutations that they think are beneficial, that they classify as beneficial, as good in their world, are actually function loss of function.
It is a pretty common theme for genetic entropy, that everything devolves, and we'll have to listen forward because this is a common theme through his entire thesis. So, and I'm not sure if there's anything else there. Mutable, you're here. Can we hear you?
Hey, I am. I gotta take care of something real quick. I'll be right in.
Okay. Okay, we'll go on. Listen to a little more of this.
So their theory is so bad that they have to grasp for straws. They can't actually find, they have only very few examples of any sort of real improvement. So they have to...
We have, I think, maybe hundreds of examples of real improvement. I mean, there's There's sickle cell anemia. There's the loss of the elephant tusks, and there are things that they consider losses, but there are also many real advantageous mutations. Just digging around a little bit, I found one in cockroaches, Patella germanica. That was an actual real improvement, consisting of 3 mutations. Found ApoA1 Milano was an actual real mutation of 1 nucleotide, I think, that ends up being a much better system.
Yeah, there's also things like the nylon digesting bacteria.
Which they I think they call that one. Do they claim epigenetics on that one? I'm not sure.
If I remember correctly, it was like it resulted from a protein cleavage or something.
Okay, I think they claim that one was always around. That bacteria always had that, but then that's kind of the whole point. There's, in fact, in some of these papers that Sal references, particularly one by Felsenstein, there are some really good examples of actual positive mutations and how this one I forget what it is, this one enzyme with a change of 1 amino acid ends up being able to attack an entirely different compound and cause a different reaction. And that's in one of the papers that I have pulled up that we'll get to, I think.
I feel like a lot of the problems people have when discussing genetic entropy in particular is I feel like there's a lot of shifting the goalposts.
Yeah.
So, they say no beneficial mutations can acquire. Then you talk about one and they say, oh, no, that's not gain of function. That's loss of function. And, well, you cite one that's gain of function and, oh, well, that one's always been around, or that one is just an adaptation from another gene or something like that, or like it was created from like a misreplication or a duplication event that later, mutated or something like that. At that point, you shifted so past the just generic, oh yeah, information's always lost, that the argument, I feel like, kind of falls apart.
Yeah. There's always something. The thing is that proteins mutate. I mean, they're not going to, like, one protein is going to change into a radically different protein with 100 different amino acids. It's going to be very small changes. And so they can always find something to kind of pick on. So anyway, I don't know if Immutable's correcting me, or I don't know what Immutable's doing. So let's see. We have survival of the sickest. I think that was on 802. So we got into that. Now, let's see what John Maddox has to say here.
Well, for me, it seems that, if you're completely sold on a theory as being the foundation for your very existence, then obviously, if your theory is only showing evidence of negative versus positive, or almost entirely negative, maybe kind of sort of a little bit of positive, then a rational person is going to have to come up with some kind of alternative solution. Otherwise, the negative is always going to outweigh the positive, right?
Sounds like a bit of projecting to me.
Yeah, there's another creationist meme there that we're grasping at straws and we have to protect our worldview so that we can sin and all this bullshit. And I think that's kind of where he was going with that.
Yeah.
So it's like, oh, it's all negative, so we have to make stuff up or something like that. I don't think they've read the literature. I don't know. Erica versus John Maddox tonight. Interesting. Go Maddox. Anyway, so that was Maddox's little input there. And I think the next thing I have is Michael Behe. I think that was
talk about this aspect of it is when creationists use the word fitness, remember that it may not mean to an evolutionary biologist what you think. Because if 90% of the beneficial mutations, that figure came from Michael Behe's peer-reviewed paper in the Biology Quarterly Review. So that's peer-reviewed scientific journal. That figure of about 90% comes from his work. It may not specifically be in that paper, but that is the figure he informally derived from his own having written that article.
I downloaded that paper and there's no 90% in there, but Behe uses 90% in about six or seven other contexts. He loves to say 90%. I mean, I found 90% and Behe all over the internet. It's pretty amazing. And I couldn't quite find, I did find his quarterly review, let's see, where he critiques Richard Lenski's E. coli as being all destructive. So it's just another blast against E. coli and Richard Lenski, which is more of the same, more of the chicken picking science. So, and let's see if he goes any further.
If 90% are bad, so when a Darwinist says, these are beneficial mutations, just step back a little bit and say, how credible is that? Because if these beneficial mutations end up being permanent part of the population, that's genetic deterioration. That's bad. So they're doing what is known as equivocating, where they say one word and it means one thing to them, and then it means something different to another. Or maybe they know in the same sentence that they're using two different meanings of the same word. They're using two different meanings of the same word, but it ends up being very misleading what is being actually argued. So when they may say, oh, fitness is increasing, it could well mean, and I'll give some examples of that the organism is losing body parts and losing organs and losing function. And let's say, well, we have all this proof that fitness is increasing. I don't know where genetic entropy comes in. And so this past January, after being recruited to work on this,
that's it. Kind of the same idea. But the implication that we're equivocating and obfuscating in order to pull the wool over whose eyes exactly? Ours? Are we trying to fool ourselves?
Apparently.
I mean, what is this big conspiracy?
One thing I was kind of confused with what he said was he said basically genetic fixation of these loss of function mutations leads to degradation of the genome.
Yeah.
Despite, I mean, you can define fitness, I guess, as something that increases your own survival, but if you're not spreading that mutation down throughout your genetic line, then it doesn't matter. Your mutation does nothing.
So Sal claims it's self-delusional equivocation that we just have to believe. So we love our, we need our theory for something. I'm not sure why do we need it, Sal? Anyway, Sal will be on later. I've got to send Sal a link. Let's see. Where are we at? We are at Muller's ratchet. He mentions Muller's limit. Okay, here's the thing. Anyway, where did 90% are deleterious come into play for Michael Behe? How is he supporting that? 90%? No. We're dealing with maybe 99% neutral, and 1%, is left over for beneficial and deleterious. Maybe a little more than that. Look, 90% are neutral and 10% maybe are deleterious or beneficial, depending on the environment. I don't know where he got that from, and that was kind of a leap. Michael Behe's quarterly review, I don't think, makes a case for that. I would be really surprised. I did not read that paper, but I do have it here.
So apparently 90% comes from the fact that much easier to break than make. So fifth grade logic in a genetics room. Okay. Yeah.
I think so. This is an interesting part right here.
We got to be careful about, our language here when we say beneficial or deleterious or neutral, because all of them could be bad. I mean, it's pretty bad when a deleterious mutation's bad, a neutral mutation's bad, and then a beneficial mutation's bad. So
Okay.
Okay. If it's a beneficial mutation that's bad, and it isn't beneficial,
How?
then why do you accept the term beneficial in the first place if you're going to change it 5 seconds from now?
Well, that's what he says. He says he shouldn't allow us this kind of language. I think he goes on and says that.
So we don't need to cut them any more slack and let them get away with the obfuscation. So that's why I'm really pointing it out. So that's why when you hear me talk about genetic entropy, you won't see the language that was in John Sanford's 2005 book, where he talks about deleterious, neutral, and beneficial, because all three could be function compromising. They could all be loss of function. All three. Okay.
So I think this is kind of the crux of what's wrong here. That Sal sees this idea of some sort of perfect design, some sort of engineering design per biolic and biophysics, where he talks about the perfectly engineered bird, you know, that can navigate with quantum effects or quantum forces or whatever.
Electromagnetic fields. It does that because of a particular ferromagnetic particle in its beak.
Right. And if that bird started running into radio towers and all of those birds died, then a loss of function, basically losing that particular piece, would be beneficial to that population.
Yeah.
And he's claiming everything is that way and trying to do away with beneficial, deleterious, and neutral, which is actually, if you look into the chemistry, if you look into how genes work, that is a very valid trichotomy, you know, those three things, because it describes how genes affect the phenotype or affect the organism. This guy in Survival of the Sickest makes a case that's kind of interesting about the interaction of life, that there's this feedback between different forms and between the forms and the environment, and it's always changing, and it isn't moving in a particular direction. So the creationist or the religious person believes fully that God created this perfect genome and it's been deteriorating ever since. So the perfect design God created, and now it's deteriorating. And as long as they have that paradigm in their minds, they're never going to be clear about what's really happening in the world. In my opinion. Right?
Yeah.
Okay.
Well, beneficial is defined by exponential growth rates, not function. Fitness defined by exponential growth rates, not function in PopGen.
Yeah.
PopGen is part of the story, but also the fitness of an organism is considered. If an organism isn't fit enough to reproduce, then it's not going to be a viable member in a population to reproduce.
Yeah. There's let's see, Muller's limit kind of goes, let's see what he says about, he uses Muller's limit. It's kind of hard to find things on Muller's limit.
Deleterious. What I did in my first debate, where I used Muller's limit and the math surrounding that, you could use that math and you don't have to worry about beneficial, neutral, or deleterious. That will cover, that math covers any definition of fitness.
Yeah, that math's pretty dense, but mostly Muller's, what is it? Muller's catastrophe?
Muller's ratchet?
Yeah, Muller's ratchet.
Yeah.
That was a asexual species that he did the modeling on, and he was trying to make a point.
Yeah.
But
It only happens in small populations of asexual haploid species with no recombination through like any sort of interplay between genetics, and also no recombination between itself because it's haploid.
Yeah.
Right. So it does result in accumulation of deleterious mutations, but that's not what we see in the world. We have populations, not colonies, like single cellular colonies.
yeah, Lenski's bacteria would have died 100 times over.
Yeah.
If that had been a salient point. Okay, Muller's limit is not the same as Muller's ratchet. Maybe Sal can post that equation for us or tell us about it later. I do have a paper on it that I downloaded, but I didn't get a chance to read. Mueller was like really upset about the atomic bomb and about radiation and testing, and he was trying to push back against that. And that's a lot of the work he did. He became obsessed with mutations, and I'm not sure what Mueller's limit does for us. Let's see what he says. Mueller's limit is used by Ono to argue for junk DNA. Okay, so I got Ono's book, and Ono's meaning for junk DNA, we could get into that in another video. Okay, so now Sal introduces his paper.
Little bit. This is an article I wrote for Creation Evolution Headlines. If you're not familiar with this, website, you may want to visit it. It is a little bit humorous. I write a very small fraction of the articles there. Most of them are written by the owner.
Okay, this is Creation News or Evolution Headlines. David Coppage. I probably shouldn't tell Sal that I subscribed today because they'll probably kick my subscription out. But I just subscribed today. So I don't think there's too much more on that. There's let's see. I think
embedded in a radio signal or in a section of.
What was that?
Yeah, don't worry about it.
Did I do that?
No, that was me.
Oh, bad you.
Playing something in the background and it bled over.
Ha! You make mistakes too. That's pretty cool.
I know. It's weird, isn't it?
Oh, look at this. This is learn so much. Great defender of the truth. Let's see. Our Load of Mutations by Mueller and Ono, 1972. So much junk in our genome. I'm going to have to, I don't think I actually have that paper. That's amazing. There's something I don't have. Okay. Let's see. Moving on. Oh, I don't know how to spell irrelevant. Let's see. Cells formal. Okay. Myth. That's next.
Thing is, the funny thing is, most biology students I know, even biology professors, don't know what Fisher's theorem is.
Here we go.
That tells me this whole thing is mostly a myth, that it's biology's central theorem. But because it was used as a myth to promote evolutionary theory, they let the myth keep getting perpetuated. See what I'm trying to say?
Yeah, I see what you're trying to say. Trying to build a straw man.
I think the primary reason it's called the fundamental theorem is because Fisher called it the fundamental theorem when he was writing his original paper.
Yeah. Yep. And there's quite a bit more in there than that fundamental theorem. And all that fundamental theorem says is if you have, let's see, it correlates variation, the amount of variation you have in fitness, with how fast fitness will change. Mm-hmm. In a population, and that's it. It's a simple statistical formula. It's mentioned in Population Genetics by Hamilton on page 203 for about 6 pages, and they explain it, and they explain, why it's important. It is important. It's important to understand how simple models would work. Very, very simplified, idealistic models work, and that's why it's important. Along with the fact that Fisher and Wright were the first ones to actually bring mathematics into this arena. Well, actually, it happened a little before that, but they kind of made it famous and brought it out. They're well respected for what they did, and they did some pretty good mathematics. So there again, I think this is just building a straw man that somehow the reason we believe in evolution is because Fisher's fundamental theorem. I don't know what Dawkins said. I've got both of Dawkins' books here, and I couldn't find anything on Fisher in them at all. So I can't find the page where Dawkins actually says that it's fundamental to biology. And Dawkins wrote in like 1972 and 1978, I think. So things were still kind of in a turmoil with Pop Gen back then. But this is just pure straw man. Build a straw man, knock it down, Sal. You can do better than this, right? Okay, so then he introduces his formal
Questions from the
paper.
audience. But let me just read the abstract so you can get a summary, and then I'll cover some of the main points. I'm not going to go deep in. I'm not going to go into the math at all. I will try to post this on my website. Actually, let me type this in the private chat. I don't know how to put it in the live. Oh, I think I could put it in the live chat. Can I put website names on the live chat? Let me try. I'm going to just try to type it in. Hang on. www.evidenceandreasons.org.
Okay, I'm not sure when he's going to talk about his paper, but how much of this do we want to go through? The paper is about, he proves the theorem and talks a little bit about, let me see, I've got it back here. I also have all of these things online, or I have them on another window, but unfortunately StreamYard won't change it, so I can have more than one source. So I switch back and forth. But basically, introduction and the problem of defining fitness. And let's see. Then he talks about Orr's paper. Let's see, where do we go for that? We could look at some of these papers. I have them on another screen. There's, let's say, the formal paper, Biophysical Fitness on 2406. We'll fast forward to that.
Evolutionary literature, FTNS relies on the definition of fitness in terms of population growth rates rather than the biophysical notions of fitness, which are more in line with the common sense intuitions of the medical and engineering community. From the perspective of the mechanical rather than the population growth notions of fitness, natural selection might be more accurately described as an agent against the increase of complexity, but rather a facilitator for the destruction of complexity. Thus, some sort of anti-weasel model of natural selection might be a better model of how selection actually works in nature rather than Dawkins' weasel or other man-made genetic algorithms. However, the main focus of this communication will provide some pedagogical insight through some simple numerical illustrations of Fisher's theorem. The hope is that this will show the general irrelevance of FT.
Right, it's irrelevant to what he's claiming. It has nothing to do with proving evolution. It is a model. It is a very simplified model, and it told us something about how fitness changes in an ideal population. And the stuff about Dawkins, the webpage, I mean, let's see, look at my webpage, see what you got to say. Look at my webpage. Okay, I have a reference to Dawkins, and then provide web pages and roadside web pages were, and Fisher calling it biology's theorem. It's not a straw man. Yeah, it is a straw man because it doesn't have anything to do with the validity of the research in evolution. You guys want to comment on that?
On Sal's comment?
Yeah. Not a straw man. Do you think it's a straw man? This going after Fisher's theorem from 1930?
I mean, it's probably not the most up-to-date thing in the world, so it seems kind of unusual to handle it that way.
Yeah. He's going after a paper from the 1930s when a lot of work in the 70s and 80s, which I pulled up earlier, has been done to argue against and for this position. Yeah, I think it's kind of disingenuous to not talk about the actual controversies within the scientific realm that happened 40 years after his publication and just talk about the original publication.
Yep. So Salvador Cordova says Sal is so eloquent in that lecture. I could listen to
I know.
that's pretty good. Love that man. Anyway, I sent him an invite, so we'll probably be letting him in here at some point. But God, I don't know if we should. He's probably just going to wreck everything. You know. So where are we at? Okay, this biophysical notion, this idea that fitness should not be defined this way. Well, if you're dealing with population genetics and you're dealing with modeling a population, you have to define it that way because that's how the alleles get into the next generation, right? I mean, this is just math. Royal Society's webpage in 2020 says biology said, so they have a name for it, Sal. Come on. It's like, I'm sorry, but we're not impressed. Okay. So he says it's irrelevant right here. Oh, this is wonderful, I think. Define the words. I think this is a really significant part.
Duration. So once you start using words like deleterious, neutral, and beneficial, you're letting them define the terms. And God bless Dr. Sanford. He advised me. He said, Salvador, whenever you let the party that defines the terms of the debate wins the debate. You can't let them define the terms for you.
So this is not a debate. This is called science. This is about figuring out what's happening in biology and the universe. It's not about winning the debate and letting us define the terms for you. These people in population genetics are the ones doing the population genetics, and they get to define the terms. You don't get to redefine them and come back at them. And I think that was indicative of something, some bad thinking, I think. Also, Standing for Truth is making an offer here. Okay, so defining the words, I thought that was important. Now we go to the paper by Orr in 2009, which I think I'm going to have to switch screens for this
Fisher
one.
was using. This is not so trivial a problem, because in a 2009 paper on fitness, Alan Orr, who's an evolutionary biologist, he quipped, biologists have offered a staggering number of definitions of fitness. There's not even one definition. There are multiple, staggering number. And worse, another great evolutionary biologist, Richard Lewontin, he lamented, it's not entirely clear what fitness is. That's actually a really bad situation. If you are going to argue a theory that evolutionary biology does this or that, and you can't even define what fitness is, that's not really a great situation. That's not a great situation. And Andreas Wagner said this. He also said, however, fitness is hard to define rigorously and even more difficult to measure. An examination of fitness and its robustness alone would thus not yield much insight into the opening questions. Instead, it is necessary to...
Okay, so I want to switch over to something else.
Well, are you going to comment on that, or?
Yeah, go ahead.
Okay. Well, I was just going to say, fitness is fairly well defined by population genetics as reproductive fitness. From paper to paper, it'll vary as what they're using to measure fitness varies. But as a whole, fitness is just reproductive success.
Right. Let's see. I am going to switch here for a minute. And this becomes kind of a problem. So share my screen again. I'll share that screen. Share. Okay, can you see that okay? Let's see how to get rid of Standing for Truth here. I don't know what he's offering exactly. He's offering to trap us on his channel so that he can badly moderate us, maybe. I don't know what he's trying
He
to
was letting Sal know that he was offering to co-moderate tonight's debate.
Oh, okay.
Yeah.
Okay. So anyway, this is the abstract. I think Sal quoted on most of this. And let's see. And I highlight important unresolved problems in understanding fitness, and that's what he does. Although biologists have offered a staggering number of definitions of fitness, they agree broadly on this. Yeah, this is the part that he highlighted. Fitness is commonly analyzed in two ways. I'm not sure if he told us about that part. One involves the actual components give rise to the difference in fitness among organisms, and the other involve mathematical measures of fitness. Then he talks about components of fitness, and he goes through and tries to make a case for a better model for fitness. And Felsenstein gets further into that, where Felsenstein says you cannot use an ordinal number to define that fitness in that equation. You have to use a matrix, and then you can multiply matrices together and do all sorts of very, very complicated math with it. And that's Felsenstein's actual criticism of Fisher. Let's see. Differences in fitness among individuals can arise from differences in performance at any of these stages. Each of these fitness components, in this case viability, mating success, and fecundity, can contribute to differences in total fitness. So they're saying that when you have overlapping populations, you have mates, you have to average the two mates together, their fitness, and you can't, it's just not as simple as what Felsenstein or what Fisher came up with.
Yeah.
Much confusion can be avoided by distinguishing between the fitness of particular individuals and a fitness as a summary statistic. So that's basically the point of this whole paper here. And I think I can put that one away and come up with another one. Let's see. I wonder if we need to look at another paper here. There's Orr. Where is Price? Where does he mention Price? Did I miss that part? Is that in another? Bear with me a little bit here. Okay, that's in a different lecture. Something interesting, I think. I'm going to try to share that lecture for just a minute. Stop screen. Share screen. I wish StreamYard would get their shit together here a little bit. Finding fitness problems with Fisher's theorem. Is that it? Oh, this is impossible to use almost. Okay, Chrome tab. Share audio. And of course, I can't find it. Unbelievable. You're kidding me. Well, guys, talk. Dead air while I'm organizing.
How about that weather?
Yeah, it's looking a little hot out there today, I'm sure. Here we go. Wow, it finally found it. Is this cool or what? There it is. Grodwall, Price. Okay. So I want to play this part.
So like 42 years after Fisher's theorem came out, this is what Price had to say. Price was also a very good math guy. He said, "It has long been a mystery how Fisher derived his famous fundamental theorem of natural selection and exactly what he meant by it. Also, he spoke of the rigor of his derivation of the theorem and of the ease of its interpretation. But others have variously described his derivation as recondite, very difficult, entirely obscure, and no one has ever found any other way to derive the result that Fisher seems to state. Hence, many authors, not reviewed here, have maintained that the theorem holds only under very special conditions, while only a few have thought that Fisher may have been correct if only we could understand what he meant." Okay, so this is...
I'm pretty sure he pulled that "if only we could understand what he meant" quote from, who was it? I'm pulling up his paper right now because I found it earlier. Oh, hello?
Yep, you're still here.
Oh, okay. I couldn't hear anyone else talking.
Oh, I'm muted. I have the paper here too.
Samir Okasha?
What's that?
Is it the Samir Okasha paper?
Fisher's fundamental theorem made clear by Price.
Oh, okay.
Let's see. You have a different one?
Yeah. There was a few... a lot of people went over Fisher's theorem, mostly because Price was very critical of it, due to him saying there's so many assumptions made that it's not really that useful. And other people like Okasha were saying that we weren't quite... the traditional interpretation wasn't quite what... Where is it? Sorry. Well, you can go ahead while I'm trying to find my quote.
Okay, so this is the part that Sal quoted in yellow, but down here it says, it will be shown here that this latter view is correct. Fisher's theorem does indeed hold with the generality that he claimed for it. The mystery and the controversy result from incomprehensibility rather than error. In other words, it was difficult to understand what Fisher was doing, and that it wasn't an error in the paper. And he goes on to talk about the meaning of the theorem and what it's actually for, how we use it, which has nothing to do with the argument against evolution. And that's the problem that I'm finding with all of this. So I think that was an example of a cherry-pick quote without including that second part. That's mostly because of the incomprehensibility. And I don't, I've got Fisher's original paper, and I think I've got his book, but there's a lot of dense math in there, and it probably was hard to, because he was kind of new at this whole thing. So
Yeah.
Anyway, okay, did you find your paper?
I found the paper. I'm trying to find the quote. But basically, Okasha was saying that modern interpretations weren't quite what Fisher was going for, since he was so early to population genetics, and he recommended that the genetic variants that Fisher was referring to should be referred to as additive genetic variants instead, and that kind of stuff.
Yeah, I played around with some of the math on that, and you get some interesting results. Exponential growth for one. And Sal did a pretty good spreadsheet on it to kind of illustrate it, which he shared with me graciously. Anyway, let's see, where are we now? We're on myth, Sal's paper, irrelevant, define the words, and then or, third or. Lewontin, let's see what he says about Lewontin.
Another great evolutionary biologist, Richard Lewontin, he lamented, it's not entirely clear what fitness is. That's actually a really bad situation. If you are going to argue a theory that evolutionary biology does this or that, and you can't even define what fitness is, that's not really a great situation. That's not a great situation. And Andreas Wagner said this. He also said, however, fitness is hard to define rigorously and even more difficult to measure. An examination of fitness and its robustness alone would thus not yield much insight into the opening questions. Instead, it is necessary to analyze on all levels of organization the systems that constitute an organism and that sustain its life. I define such systems loosely as assemblies of parts that carry out well-defined functions. I'd like to focus on that last sentence. This is an evolutionary biologist speaking. He says, I define such systems loosely as assemblies of parts that carry out well-defined biological functions.
Okay, so I was going to make a point for irreducible complexity here. But anyway, the Lewontin paper, Taxonomic Space, a wonderful read. It's amazing. It was in some journal. It's called The Four Complications in Understanding the Evolutionary Process. Mm-hmm. And he goes on, I will link this paper if I can. I think this was available free. I'm not sure if I bought it or not. But he goes on to define, he talks about the complexity of defining fitness in population genetics. And he recommends matrices. And he talks about some examples with Drosophila and a few bacteria that they played around with, and exactly what is going on here. And nowhere does he disparage beneficial mutations or the possibility of evolution, or Fisher, for that matter. He says the difficulties of the concept of fitness are unfortunately much deeper than the problem of frequency and density dependence. The problem is that it is not entirely clear what fitness is. And I think Sal quotes that part of it. And I'm not sure what else I've highlighted here. But anyway, it's like 4 pages. It's a quick read. And it's a really good idea of how we might proceed in being more careful with fitness models. That's kind of what all of this is about, is getting better at population genetics. If you look through the books I have, we have gotten a lot better at population genetics in the last 10, 20 years. There's quite a bit of it. See what we got here. I don't know if Sal's going to join us or not. He hasn't popped in yet. I did send you. Okay, you found the paper. 2003 Santa Fe is free. I'm assuming he is talking about Lewontin. Okay, Lewontin then practically says fitness is nothing more than reproductive schedules themselves. That's a restatement of population size over time. Yeah, it has to do with reproductive schedules, but those become very complicated. So, Sal, I sent you a link in your email so you could come in here. There's no getting better at pop gen as far as what? Grodwall? Yeah, I've got the Grodwall paper. It's gigantic. He doesn't say anything like what you think it does. Sorry, Sal. Oh, yeah, Grodwell. Okay, should we let him in? Huh? You let this guy in here? I don't know. We don't just let anyone in here.
It's a very exclusive club.
Anyway, what do you got to say for yourself, Sal?
Oh, well, thanks for highlighting my work. It's better to be criticized than ignored. So I thank all my anti-fan clubs here and love to you all. No hate. We can get along, which is a lot better than we could say for other pockets of the country. People just killing each other. We can disagree, and we can still cooperate, and I think that's important. So I appreciate the criticisms, and I'll take them into consideration. I don't have the reason I do provide references is so people can see the whole document. It's not necessarily productive to just dump all the documents in their entirety there. I was highlighting kind of the ironies, just like with the Price paper. Yes, Price did say Fisher's theorem is correct as far as the domain of application and under the assumptions. But my point was, it's kind of embarrassing that mythology is biology's central theorem and no one understood it. That was really the point.
But who said it's the central theorem? I mean, who said it was central to why I believe in evolution? I think you're the one that made it.
I didn't.
In the forefront of my mind.
I was just saying that's a myth. I pointed out biology professors don't believe that. Biology students don't believe that, but it's a myth that's perpetuated. I was just merely pointing out the myth. And 22,000 papers. I mean, that's a myth that's circulated. There are myths that are circulated that aren't true.
It's like Charles Darwin. Who gives a damn? I mean, he's an old dude from way back. And it's just like, I haven't read Origin of the Species, and I don't intend to.
So I was not saying. I explicitly said that biology teachers, most of them, or even professors or students, wouldn't know that it's the central theorem of biology. I was just really making more fun of Richard Dawkins, that's a little swipe at his general cluelessness, because I understand Fisher's theorem better than he does. And if he understood a little bit more about fitness, the definition of fitness, he wouldn't have come up with something as silly as weasel. Because if the definition of fitness has to do with population growth, it's decoupled from the evolution of complexity. That was really my point. But I can see how you could not quite get what I was communicating, and that's fair. That's a fair criticism. So
if creationists hadn't come up with such inane, simplistic arguments against mutation, calling it random chance, then Dawkins wouldn't have had to come up with something as simplistic as weasel to counter your simplistic arguments, because you're always talking about random chance, trying to make it like proteins just randomly put themselves together. And then weasel was meant to show you that random chance with selective pressure can actually create something very quickly. And that's all Weasel was. And I'm not going to defend Dawkins because he's an interesting character, and he's sort of an old player in this field. He's he's a legend, but he's
he's very good at English.
In it.
I wish and everyone should wish they could write as well as he does. His command of the English language is tremendous. He's very well read for English literature and poetry, and I read his book. It's just great for learning how to make an argument and how to articulate it. Even creationists have said he argued his case very well. Doesn't mean that he's right, but he argued his case very well.
I envy his royalties.
Anyway, I don't want to disrupt your. I really do appreciate your criticisms, and I think they're. I can understand how you may have interpreted what I've said, and maybe I can work on trying to be a little bit more clear about what my argument really is, because there seems to be some ambiguity about what I'm really attacking, and so
maybe the four of us can work that out right now. So
okay,
Immutable, you had something to say, or was that Walker?
Well, when he was talking about Dawkins earlier, I was just saying that Fisher's fundamental theorem, like one of the biggest assumptions it relies on, is its gene-centered view of evolution, which is something that Dawkins also is like a super big proponent of, with like selfish gene and all that, which is experienced like that. That's probably the result, or the number one point for most of his criticism, right? So,
well,
yeah, and that was apt at at the time they did that. Basically, that was what we knew. We did not have the genome sequenced yet. We didn't have the last 20 years of research under our belts.
So, let me try to communicate then what I was really going after. The first thing is just to educate people what Fisher's theorem is, but it actually, in the process of doing that, it's a way to communicate how population genetics defines fitness. Whether good or bad, people should know it's not the same as the way people in the medical profession and the engineering profession define fitness. That's why when we talk about deterioration of the genome, if one person has one definition of fitness and another person has a different, there's going to be problems. We don't have to say one's good or bad, although I think the population genetic definition is horrible, but we don't have to even go that far to decide that. We can say the way a medical doctor might consider what constitutes fit may not agree with the way population geneticists and evolutionary biologists conceive of fitness. I think that's clarifying the argument, and that has some value.
Yeah, and that's the major pushback I have against your idea here, is that we don't need no engineer telling us how evolution works, and we don't need no doctor telling us how evolution works. They are not studying evolution. There's biologists are studying evolution. There is no engineering version of fitness, and that's where I think you're going back to your worldview, and you're letting your worldview completely modify how you think of this. It has to do with reproductive success.
I think that's fair.
Yeah,
I think that's fair. I think what you said is accurate. You have at least identified. This is where we how to define fitness, and maybe that's where we'll leave it. At least we know why we disagree, and so you said that we don't need medical doctors and engineers telling us how evolution works,
right?
Okay.
Yeah, let's see here. Do we have, let's see, it's Orrin Dennett. I'm trying to find the right paper here. There's a paper that talks about, you mentioned it, which one is it where you talk about complex periods of complexification? That basically there's
genome reduction is the dominant mode of evolution. It's by Wolf and Koonin in Bioessays. That's off the top of my head. I don't have the citation. It's in my paper, but I remember it. Reductive genome reduction. So I use the word reductive evolution because we're seeing more and more papers use the word reductive evolution.
Yep. Wolf and Kuhnen. Let's see. I purchased Wagner's book, but it hasn't arrived yet.
So
It's got a paper here too for complications. I'm trying to find Wolf and Kuhnen.
yeah, I'll try to help out with this. By the way, I really do appreciate the fact you've looked up the references, and even though you feel that I didn't give a satisfactory quote, that's something I can improve on, and maybe I could just point out.
Do the whole quote.
Yeah. No, well, you've highlighted what I can include the next time, so that I don't get dinged for whatever. And I mean, that's fair. That's a fair criticism, and it's something I can improve on. So I have no problem with that.
Okay, it seems though we got you here. We don't have to go through your video anymore. I'm going to stop this screen and take a look at Wolf and Kuhnen. Did I not highlight this stuff? What do they talk about? That is that in the abstract? Yeah. Okay. Got it. I got it.
Now they're talking more about what they go through evolutionary history, which I don't accept, but even under that, so they had these periods. Yep, that's it. They weren't really going. They weren't going through modern day experiments. There's lots of experiments with reductive evolution in the modern day.
Yeah, quantitatively, the evolution of genomes appears to be dominated by reduction and simplification, punctuated by episodes of complexification. And the thing is, if you quote them as an authority, how can you disagree with the rest of the paper, where they talk about how complexity increases, and either decrease or increase or decrease? It doesn't matter which way it goes. I mean, sometimes a beneficial mutation is going to be reductive, like the elephant losing its tusks. And that isn't a problem for evolution at all, because this complexity does appear periodically, punctuated equilibrium or whatever. And here's genome reduction pervades evolution, and that's normal. And I think Lenski's seeing that in some of his bacteria. But what Lenski is also seeing in his experiment is he's seeing that certain strains of the bacteria went into hypermutation mode, where they started to build new things when they were under stress. And there's a remarkable paper that you turned me on to here. I think it's by Ubif. Okay, it's by Didier Ubif, where he talks about just this. He talks about how there are a number of physiological conditions that increase mutations in certain areas when an organism is under stress. When a species is dying, it'll suddenly start to hypermutate. And I think we saw this in the Cambrian explosion. And this is what happens. It's punctuated complexity.
I think you're very kind of you to think I could, but it might have been someone else.
No, it was Ubif. It was.
Who's Ubif?
Aubif. You referenced him. You're the one that got me into him. Let's see. Or Gladwell. Where's my man?
it may not have been a direct reference. I mean, I'm not saying you're wrong. I just don't remember ever. I tend to remember at least the big references. You cite an important complication here. I will cite Kuhnen as an authority, but the way that I'm citing these people is I'm trying to point out what their conclusions say doesn't necessarily agree with their evolutionary beliefs. What their conclusions and the facts that they lay out. And I don't quite know how to say, well, no, he doesn't. I mean, the accurate thing to say is Kuhnen is convinced of evolution, but a lot of what he lays out is just pure speculation with no mechanism. He'll assert it, but it doesn't mean that he's correct. But he is, I need to be able to say, okay, these are, if we accept this trajectory, where he said genome loss is the dominant mode of evolution most of the time, I need to be able to say he accepts that, but then it just looks kind of like nonsensical unless one is invoking miracles. So maybe
to you,
huh?
to you, it looks here. It is. It's Didier Oubif is how you pronounce that in French. And this is a paper that you refer to somewhere. I'm not sure where. Physiochemical Foundations of Life, and I think you quoted some of his comments here. And he's talking about how complexity happens and how reversions happen. Very interesting paper.
I don't remember that. I don't ever remember reading that. I'm not disputing.
Really?
It may have been. It may have been like a secondary. Maybe it's a quote of a quote. That
Yeah,
ended up in UBIF.
Probably
So-
a quote that you did, and I went ahead and found it. I dug it out of the internets, and this is pretty cool. And he's also talking about possibilities for abiogenesis in this paper. So I want to thank you for giving me this, because if I ever argue abiogenesis, this is probably going to be my primary source. It's a wonderful paper. So,
yeah.
By Didier Oubif. I wanted to mention Price. Price died, I think, in 1981 or something, or 76. You remember you quoted Price? Price created some mathematics that had to do with altruism and showing how altruism would grow in a population. And he created a formula that he became so enamored with that he applied it to his life, and he went out and started helping all these homeless people and alcoholics, and they stole everything he had and wrecked his life, and he was suffering from depression. He ended up living in his garage, and he cut his carotid artery with a razor and committed suicide. That's what happened to Price. Very interesting man, but tragic story.
He was, some accounts describing as a creationist.
Oh,
Did you know that?
Dead ones. Yeah, you can claim that about dead ones. No, I would love to see your references or proof on that one. Maybe, it's hard to say. The guy was, a little bit off. I mean, anybody that takes a razor to their carotid artery.
Yeah. No. I should put together one that kind of. I mean, it's very hard to set the record straight because, he is a dead guy. He can't speak for himself. But the accounts were that he said he was a creationist. I don't know how he was able to reconcile that with his evolutionary biology, but he was very respected. So that let's just file that away. That should be something that should be good for someone to pursue.
I'd be interested in that.
Sure, I think everyone would be. Yeah. But it's a compelling, sad story. He seems like an otherwise lovely man that he would devote his life to helping the underprivileged. So,
but as you have illustrated, even really intelligent people can be dead wrong. Bang, zoom, zing. Okay, Walker, immutable. Grill this guy.
Oh gosh, on anything, or because y'all have been talking about like papers and stuff I'd never heard of, so I didn't want to, interject there on stuff because I'd just be talking out of my ass at that point.
Well, and I'm sorry, I didn't mean to interrupt. Thank you for joining us. Go ahead. I'm sorry.
Oh, well, I was just gonna say, I guess bringing it back to fitness. Would you consider someone like a sterile Superman or something more fit than a regular individual? Because going by, engineering principles, I guess, this guy can fly, he can throw around 600 pounds, but he's not going to pass on any of that phenotypic trait to his offspring. So as far as population genetics go, it doesn't matter, right?
I think that's an interesting question. First off, I haven't completely come up with a way to address it, but the way that it's done, going back to the sterile Superman, because there's a kind of a quasi example of that. We have a space shuttle. It's sterile, so to speak. It's not going to reproduce itself, but it's fit to fly in space. Same with a submarine. It's kind of a sterile Superman undersea. It's fit to operate undersea. Same for an airplane. So the engineering definition of fitness is the fitness to operate in a certain environment. Independent. It has nothing to do with whether it can reproduce or not. It's the capabilities and the appropriateness that that a device has in relation to its environment. And that's what actually caught my attention in Lewontin's paper. He said Darwin's idea was, and I think Lewontin wasn't exactly correct, because I went back and read Origin of Species to parts of it to try to see what Lewontin was seeing. In a sense, here's a good example. Darwin said the honeycomb is perfect. Let's see if I have that one. It's a beautiful quote, and it's perfect in the sense if we wanted to minimize the amount of beeswax needed to construct a structure, the honeycomb is perfect with that octagon. And there is a mathematical conjecture called the honeycomb conjecture that was finally proven in 1999. So in a sense, what's happening is we define fitness not so much in broad terms like Superman being sterile, but meeting some hypothetical specification. Now we could always create specifications that can kind of match the optimal stuff, like the bee honeycomb. That is, it's like, well, yeah, it's not so outrageous that some engineer would want to minimize the amount of materials that he's using to construct a certain structure. And let's see if I could find the quote by Combe.
See, I think you're making the same error that Lewontin is charging, that this some ordinal or some idea of fitness. Basically, what we have to look at is what fitness actually is in a population. And I think, is it Lewontin or one of these guys also makes the case that you're not just looking at fitness in a population, you're looking at very, very complicated ecological relationships, and that when an organism is more fit and it produces more members of its species, it oftentimes kills itself or reduces itself because it modifies its environment in such a way that it feeds back into the equation. Now fitness is going to be something else, and you're going to end up with these niches. And the other thing is that there are other life forms that are either being eaten or eating you, and this all becomes very complicated. But we might read this. I'm not sure if I remember what his conclusion was. But yeah, go ahead and find that quote. But I understand what you're saying about, the wonders of life and this fine tuning of organisms for certain niches. And that last paper I showed with was it Ubif? No, it was Felsenstein, I think. The one from the journal. He makes really good cases about that. It's really a wonderful read, that paper. It appears that the resolution of the confusions about fitness requires 3 clarifications. First, we must not conflate the notion of reproductive fitness with the Darwinian metaphor. Okay, so he's going after Darwin here. And saying,
I'd like to hear what he has to say, if you could share it.
Am I not? I'm sharing the screen.
Oh, I'm sorry, I can't. I was trying to read 2 screens at once. I'm sorry.
Yeah, I don't. I would prefer somebody else read it out loud because I don't talk so well. So
I can be the audiobook narrator.
Go ahead. You're good.
All right. So do you want me to just start from the whole paragraph?
Yeah.
Okay. It appears that the resolution of the confusions about fitness requires 3 clarifications. First, we must not conflate the general notion, or the genetical notion of reproductive fitness with the Darwinian metaphor of organisms fitting more or less into an environmental niche. Second, we require the abandonment of the attempt to make general quantitative dynamical theory of evolutionary change into which a unitary scalar reproductive fitness appears as a parameter, and the acceptance of a diversity of specific dynamical models in which reproduction among heritable types appears in structurally quite specific ways. Finally, if reproductive fitness differences are to predict or explain changes in representation of types in evolution, it requires, in each case, a decision about the nature of the scale on which the representation of different types is to be measured.
Yeah, I think he's saying it's complicated.
Where is this from? This is actually pretty good.
This is the paper that you referenced. I got to thank you for all these papers we're showing today. This is the confusion of fitness.
Oh, you're the one who found this one.
Yeah.
Ariu. Okay.
Yeah.
Maybe I'll include that in my paper. That's Lewontin.
Yep.
I need to include that one in my paper.
Yeah, it's kind of a long read. I think it's, I forget how many pages it is, like 26 pages or something.
Ariu. Confusions over fitness. I mean, did you like what he had to say?
Yeah, but he sounded a little whiny at first, but then he was going on about the explanandum and the explanans. And every time I saw that in philosophy, I always got a little pissed off at people. It's like when you gotta resort to the explanandum and the explanans, I always think that a person may be talking out of their ass. But anyway, but he makes a good case, and he talks about all these different cases for. He breaks it out, I think, into different little. I think he's the one with he's the one with the arrows, natural properties to fitness to environment. But he's very much talking about what you are concerned with, and the kind of the difference between how we think about fitness. You know, we think of like on Standing for Truth, that Poor Souls channel. He talks about Neanderthals. In one part of his video, in the beginning of his video, him and Ramat talk about Neanderthals and how strong they were and how big their brains were. And at the end of the video, he's talking about how Neanderthals were inbred and weak and they died out. And then at the beginning of his video, he's talking about chimpanzees and how they can bench press 600 pounds and we can't, and we suck and we can't go out in the sun because we don't have fur, and chimps can swing through the trees and we can't. And then at the end of the video, he's talking about how chimpanzees are going extinct from genetic entropy. So, I mean, this idea that stronger, bigger, faster is better is ridiculous. It just, this is what we're talking about with evolution of complex ecosystems.
Well, going back to, I mean, this is, I'm trying to elaborate on what Walking Fish was talking, raised the issue about the sterile Superman. So from an engineering standpoint, even if we have a space shuttle sitting, say, in a hangar where it's not really operating, we can imagine situations where it's well adapted to an environment like outer space, even if it's not presently there. That's the engineering way of looking at things. So the way that we would evaluate optimality is not that it's omnipotent or all-powerful, but given the materials that it's constructed with, we can identify environments where it's optimally suited. It's optimally constructed for that environment. So a submarine is not optimally constructed to operate on land, and but it is very well optimally suited to operate underwater for many months. And that's so when we're trying to talk about fitness in the engineering sense, we have all these specification sheets. So what do we do with situations where we don't have specifications sheets? We can look at convergences, such as what Bialek does, where he just uses, like, say, the eyes of insects. He was saying it obeys an engineering principle. You could see all these insects that have the size of the insect is different by an order of, factor of 10, but yet the eyes are constructed to obey a certain engineering principle where it's optimized for focus. The construction of the eyes and the lenses, and then the receptors. So there are various ways that it can be arrived at what the definition of fit means or what is maximally possible. For example, just like, say, the homochirality in amino acids, you can't get more perfect than homochiral in terms of ordering or organization. You can't make something more than 100%. So one way it can be framed is when something is operating at 100% of what is physically possible. That's the case with the shark. Sensing of electric fields. I talked to physicists who work on radar and electric sensing. They said, yeah, that's about the limit that physics would allow. So there are lots of things where we could say, given the materials we have, this is operating at the optimal limit. BioLec identified that in the process of development, a lot of the blastomere cell types can count molecules. You can't count any more precisely than individual molecules. And he also gave examples of E. coli. So those are the definitions of fitness. And then I gave the one of the potassium ion channel. If it's going to handle potassium as an ion channel, it has to be constructed a certain way that's optimal to be able to fit in the cell membrane. Deviations from that will cause it, at best, to maybe not. It may not damage it, but it will still damage it. You can't really improve upon it. So I'm kind of, maybe 20 years ago we didn't have the development that we have in biophysics now, but that's the way we were. I'm pleased to see people are looking at it. So I'm not saying that this is going to resolve our disagreement about how we ought to define fitness, but I think we've highlighted there's definitely a divide. There's definitely a divide between the engineers and medical doctors versus evolutionary biologists. And maybe that's about all we can agree to disagree on.
I think there's a very good reason why evolutionary biologists and population geneticists aren't using that definition. And it's simply because, an analogy to a space shuttle and a sub makes sense if you're looking at it from exclusively functionality. But nature doesn't make sense, and also nature reproduces, right? Shuttles don't reproduce. You're not going to have. I guess they can assisted if someone's copying it. But the function of the space shuttle is a lot more relevant to the space shuttle than the function of a stag's antlers are to the stag, right? The function of the stag's antlers are more for sexual display than they are for, any sort of functional, functional reasons, right?
Yeah. Yeah, it doesn't make engineering sense exactly. Isn't quite how it works.
Is the antler considered? I actually don't know. Would the biosemiotic people consider that a method of signaling?
Yes.
Okay.
Yeah.
Okay.
And
yeah.
I highlighted a bunch of stuff in this paper. I also have a coffee stain over here. I don't know how to do that online, but anyway, I've got the paper in front of me, and I had some highlights. But I was interested. The real problem for the evolutionist. So if this guy Lewontin's using the word evolutionist, I think I'm going to create a religion called evolutionism.
Did he use the word evolutionist?
Right here in red.
Oh man, good for him.
Yeah, it's red, right? The evolutionist.
Yeah, I knew there was a reason I like this guy.
Yeah, exactly. Yeah, you guys talk about evolutionism. So from now on, I'm going to identify as an evolutionist, and it's my religion, and I believe in it, and I have faith in it. So there you go. Now what the hell are you going to pick on?
Yeah, what am I going to do now? I did find the quote from Darwin. So whenever you're ready, I don't want to.
You did? Okay. You can. Well, first of all, I wanted to look at this paper a little bit. Now, he talks about taxonomic space, and it's a space of organisms that has a huge number of dimensions, each one corresponding to some phenotypic character. And he used that basically in how to, he makes the case of he makes the case down here that the real problem for the evolutionist is not to explain the kinds of organism that have actually ever existed. The real problem is to explain why there are organisms that never existed. And he uses an example, which is clever. Snakes live in grass, but there are no grass-eating snakes. So that's one niche that's never been like he makes the case that there are all these taxonomic spaces for which we do not have organisms. And then he goes on to talk about pathways. And this paper is a must read for everybody. He talks about how there are some pathways that aren't accessible. You can't get there from here. You know, the old joke, how do I get to 4th and Main? You can't get there from here. Basically, that is true of many species. And that's why vertebrates, you know, are not going to turn into fleas, right? Because you can't get there from here. So anyway, I thought it was an interesting paper, but
I wanted to acknowledge Walker's point about the antlers. That's something I haven't thought about. So kudos to you. That's something I need to account for, because I really don't have much of an alternative, like general definition for fitness. Mm-hmm. And it's a fair point to say I didn't state what my alternative is, except to say vaguely, you know, in the engineering medical sense, there is a case-by-case basis, and maybe that's as good as I can get it. Yeah. So I just wanted to say thank you. That was a really good point.
Thank you. Well, I mean, just sexual selection pressures in general, right? Like they don't necessarily have a survival benefit for the organism. In some cases, they can even detract from the survival of the specific organism. But if it helps you, you know, spread that phenotype onto the next generation, then it'll just inherently pass itself on, right? If it can increase your reproductive success, then it'll increase your genotype's proportion to the population as a whole. You know.
So I wanted to acknowledge that. I felt that that was such a good point. So I just wanted to repeat this. There are lots of examples like that, like the peacock's tail.
Yeah.
Which. So anyway, I'll read this from Origin of Species. So thank you. That was a very good point.
Thank you.
Worth considering. Origin of Species. I will not here enter on minute details on this subject, but will merely give an outline of the conclusions at which I have arrived. He must be a dull man who can examine the exquisite structure of a comb, that's the honeycomb, so beautifully adapted to its end, without enthusiastic admiration. We hear from mathematicians that bees have practically solved a recondite problem and have made their cells of the proper shape to hold the greatest possible amount of honey, with the least possible consumption of precious wax in their construction. It has been remarked that a skillful workman with fitting tools and measures would find it very difficult to make cells of wax of the true form, though this is perfectly effected by a crowd of bees working in a dark hive. Grant whatever instincts you please, and it seems at first quite inconceivable how they can make all the necessary angles and planes, or even perceive when they are correctly made. So that's not directly related to reproductive success. It is indirectly related to reproductive success that they can build these things. But from an engineering perspective, that's the best example I could find in Origin of Species, where Darwin is kind of using kind of an engineering like definition of optimal, where he's talking about using the least amount of wax to be able to hold the largest amount of honey. It's probably a little bit more complex than that. The honeycomb conjecture goes into the details, just painful. It took only in 1999 for someone to finally actually prove the conjecture. So.
Okay.
Well, that's all I had. I think you've identified what I can articulate what my lecture and my paper of Fisher's theorem is. I want to at least say this is what the population genetic definition of fitness is. I may say some negative things about it, but people will at least learn the population genetic definition. That's great. And, I use Fisher's theorem as a way to introduce the terms like mean, fitness, and variance, because when people talk about fitness increasing, it took a long time before I realized they're talking about the mean fitness, that W bar
Yeah.
term.
Yeah.
Well, I think it is really fair that you're trying to demonstrate the distinction in a lot of ways between like how lay people when fitness is used in everyday terms versus how it's used in biological settings, right? Because I definitely get how that can get confusing if someone's not necessarily familiar with like the specific subfield.
So, but where I was headed, and this is where I was being very critical. I said, if we're defining fitness in terms of reproductive success, it is now formally decoupled from the evolution of complexity. It's not inevitable, as Dawkins might be insinuating in Blind Watchmaker, and
Well, no,
it's
shame
probably.
on him. Did he say that? Did Dawkins say that complexity was coupled to fitness?
Let me look at that. I don't have a specific quote. So thank you.
If you did, shame on him.
Okay, thank you for challenging me on that. And I do have a copy of Blind Watchmaker, which I may have filed away. To the extent anyone uses that, I can ding them on it.
This book here by Crow and Kimura,
Yeah.
Population Genetics, is from 1970, and population genetics is a little bit bigger than just Fisher's theorem. But the interesting thing I found, and I told you about this, is that I don't know if you can see that in the camera. There are 60 references to Fisher in this book from 1970. So Fisher is referred, and I think only one or two of the references are to Fisher's fundamental theorem. The rest of it is just to the rest of his work. And this book is intensely dense. Now, this one by Hamilton, Population Genetics by Hamilton, mentions Fisher in 6 pages on page 203, and it's not considered fundamental, but they make the point about this mean fitness and the variation increasing the change in fitness of a population. And that's the only point they make, that there's, that you did a really good job of showing that equation and explaining.
Oh, well, thank you. Thanks for the kind words.
But
so I mean, maybe,
I've
maybe
been
what
light
I
on
said is not all bad. Okay, if you've gotten something good out of it, then maybe that's the best we could hope for.
Yeah, I've been a little light on kind words for you today, so
that's all right.
Anyway, I want to. He's going to be kind of mad, but this is Loki, and he wants to say hi. Say hi, Loki. Now he's mad.
Loki.
He has a brother named Thor who has a white nose, but he's always coming up here messing with my mouse.
Yeah.
But anyway, so
thanks.
So the pushback is against this idea of perfection and engineering perfection. Complexity arises in bursts when there's massive amounts of mutation, and there's speciation, splits, there's isolation, speciation. You're going to end up with complexity, and it can happen in plants through chromosome duplication. It happens in mice that way, and you're right. The paper where you said he talks about complexification, but then he doesn't explain how it happened, right? Well, that is the whole of what evolutionary research is doing right now, is explaining how that happens. And I've run into, that paper I showed you by Lewontin, he talks about this one protein that had a one amino. It was for some hydrolysis reaction, and there was one nucleotide changed, which changed it from one amino acid to another. I think it was asparagine to glycine. It completely changed what the chemical reaction that particular protein could do. It all of a sudden it had something to do with phosphorylation, and it attacked a particular insecticide that they were using on these bugs that there's some sort of a cow fly, and the species changed and evolved because of that one change. It developed the ability to attack an insecticide and tear it apart. And that was a one amino acid change.
Actually, I think that might be an arginine.
It was arginine to glycine, and it was in.
That's very interesting. The only reason I know that is I study phosphorylations in the enzyme I'm studying right now, and eukaryotes they phosphorylate arginine, serine, and threonine.
Okay.
And so sorry, that had nothing to do with anything we're saying.
Well, Newcomb and Campbell et al. Found that the acquisition of organophosphate herbicide resistance in the blowfly, it's Lucilia caprina, is a consequence of a single amino acid substitution in the active site of a carboxylesterase that abolished that enzyme's specificity and converted the enzyme to an organophosphatase. So it was able to take down an entirely different chemical. And that is how protein, that's how complexity developed. And if you look at embryology, I mean, it gets even wilder. You can have just one, these tiny, tiny changes can change the fields in the embryo and changes the way they develop. And you can end up with limbs and very different body plans with very few mutations. And anyway, I got to thank you for all these wonderful papers that you got me reading.
You're welcome. I'm glad I could do something. Maybe
you have bolstered my case for evolution by a factor of 100. Thank you, Sal.
Oh, you're more than welcome.
Yep.
I'm glad I could be of use.
What I'd do without you.
Yeah, what would you do without me, man?
I'd probably become a creationist without you. You know?
Yeah. Well, no. See, now you know that Lewontin and Felsenstein used the word evolutionist, so you learned something.
That is true. I guess I can't call that term as I don't know, fallacious. I guess or not fallacious, but poisoning the well almost. But or at least that's how I usually see it. But
well, it's usually a slam, and I never quite understood. The accusation is that we have a religion. I thought you guys loved religion. I don't quite understand. I mean, you should be happy that we have a religion. You should be patting us on the back. We have faith.
Only one religion is true.
Ah, I see. Okay, guys, you want to cut it?
We don't need to go there. We don't need to be fighting anymore. So, but are
we fighting?
No, we're not fighting. You gave me some very good critiques, and
I have. You have to. Well, in fact, take all those. Take that entire piece on Fisher's theorem and burn that, and come up with something much better, much stronger.
Can I ask? Is it okay if I take this? I'll put it on one of my channels if that's all right with you.
Oh yeah, you can take this.
Yeah, go for it.
All right, thanks.
I want to thank you for your references. The fact that you referenced everything you did. I don't know if you can see my whiteboard back there, but it says Maddox, Buck, Bagak, because he's afraid to debate me. But anyway, Maddox is mad at me because I asked him for a paper, right? I mean, what else did I do to Maddox besides ask him for a link? I went over the top. I know. I said lie, Maddox, whatever.
I think you guys really love each other. It's just,
we do. I mean, I really do.
I think you're just not wanting to admit it. You're obsessed with each other.
Yeah,
I think all that's just a show.
Yeah, I think, I'm going to invite him deer hunting, in fact. Him and I are going to go up north and go deer hunting together. I mean, we're bros, but right now he won't even talk to me. He won't respond to me. He's like, so Buck, Bagak, he's afraid to debate me. And I think he is afraid to debate me because I'm an actual programmer and I actually know a little bit about genetics, and he can't pull this bullshit with me. And I also really blindsided him with not refusing to say that logic was immaterial, which from my philosophy, which I've done a great deal of, I cannot say those words. I cannot say logic is immaterial because I have reasons to believe that it is solidly based in naturalism. So, but that really screwed him up. He got mad at me. And then I asked him for links. I asked you for links. You send me everything. You're wonderful.
Oh, thanks.
Keep
No,
him.
I mean,
Keep him.
it's okay to be accountable, and the other thing is I'm planning to create college level courses to teach creationists. I want to make sure they get the references right, and I want them to hear your critiques, because I think that's only fair, and they should be well equipped to hear both sides of the argument. And I'm fair.
Yes.
I'm fair with that. That's the
Are they
most.
going to be like publicly available, or?
I'm sorry. Yes.
I
it's
said,
gonna
are they going to be publicly available?
Oh,
or
yeah,
is it going to
yeah,
be through
and-
universities? Okay.
Yeah,
Interesting.
I haven't built it out yet. I'm working with some professors who are creationists who teach at secular colleges.
Cool.
So they're coming out of the woodwork. One of them is Change Tan. She's at Missouri. She's a Harvard postdoc. Very, very bright, but she can't talk. She just she has said that she doesn't get great student evaluations. She's more of a laboratory person, and they're very fine scientists that are that way. So
Boy, she could write. I mean that I don't know how much help she had with that book, but it's wonderfully written.
Well, thank you.
Wait, who is
Bob
this?
Stadler's very good with English. She's very good with the technical stuff.
Yeah.
So the unpublished version of her book is really good from a technical side. It's unreadable from the popular side. So it's really good that Rob Stadler came in. And so where it's very lucid and the English is just perfect, that's definitely Rob.
Yeah. I want to ask you about that after we go offline, that unpublished version. But let's see, what else did I want to cover? We're planning on doing some, hopefully, it might be a year out or whatever, but I'm working with a logic professor from Normandale Community College in Minnesota, and he's written a textbook, and we're going to be doing some logic coursework and some logic. Hopefully, if I get my act together and start programming more seriously, we're going to have calculators for solving logical problems and proving arguments, that sort of thing. And we're also going to be with Immutable. We're planning on doing some chemistry work and some lectures. And then I'm going to be, hopefully, if I ever figure out how to use the computer to produce content, there's a lot of stuff that I want to do on genetics. And for every creationist lecture you put out, I'm hoping to counter you. I'm hoping to.
Well, there'll be a lot that is not creationist material. Actually, I mean, I appreciate Walking Fish's interest in some of my work, but just even the section I had in my paper on just proving Fisher's theorem is like one example. This should not be controversial. I mean, it's a lot of it's taken from Felsenstein's book, but I think I added some stuff because to it that clarifies it, because even me with a math degree and a physics degree, I was just like, that notation that they were using was just like throwing me off, and just like, okay. So I actually talked to Joe and I said, is this what this symbol means? Because I don't see it used that way. Now I'm not a statistician, so I went back there and I said, okay, this will satisfy a mathematician. They'll like the way I did the symbols.
That's the problem with mathematics is the change of symbols, from one book to another, one paper to another. They use entirely different symbols, and then they don't explain them if they're bad authors, and they usually are, and it really throws you off.
Right.
But
and then one from Mueller's limit. There's nothing on, and Mueller's limit is a term that I coined just because, I needed to give it a name and associate it. It's 1.0 for humans. It's a different limit for other species, and I can do something like that. That shouldn't be controversial. So that's more of what I enjoy doing. Anyway, the debate scene's not really my thing. I want to be more of a scholar. And
Can I ask a quick question?
Yeah.
What do you mean by Mueller's limit? That's not something I'd heard before today.
Oh, okay. So Mueller said in his paper, 1950 paper, a little history, where the term junk DNA came from. It's widely attributed to Susumu Ono. His 1972, I I guess it was a conference proceeding. It's not a peer-reviewed article like in a journal, and it's not on many. There are not many places you could find it, but the term junk DNA came from Susumu Ono.
Is it in there?
Best as I could tell, huh?
Does he talk about it in his book? Oh no,
I didn't read that one. It's from
okay.
it's from the Brookhaven Symposium. It's like so much junk in our genome, and it was after that the term junk DNA came about or was used.
Okay, we need a reference to that paper
I can put it for you here.
in the chat.
Yeah, I'll put it in. It's important enough because I want to get this right. Because if I tell this on my lectures, I want it to be right. So, I mean, I value the fact you're going to look this up, and if I misquote someone and you, hey Sal, you didn't quote enough, it's like, okay, I want to do this fair, and I where we could do it as best as possible without just reprinting everything.
Oh, did you do it in private chat?
Yeah,
Okay.
It's a little hard to do it let me put it in the live chat. So,
Oh, do I have to give you like a wrench or something to do live chat?
I don't know how to, I have to go on another computer to put it in live chat.
Oh, that's
so.
okay. I'll copy it over. I'll do it.
Oh,
right now.
thanks.
Yep.
So I have that way I could also monitor. So back to this thing about Mueller's limit. Can I share my screen?
Sure.
Thanks. Share the screen.
I have a cat in my way, so I'm having trouble with my mouse. I have to keep sliding them around. So when I have fun, we have cats.
So how did Ono arrive at this? So their understanding of the genome was not as, it's 1972 is what, 50 years ago?
Yeah.
Yeah, almost 50 years ago. Okay, so their understanding of the genome is 50 years obsolete, but the limit is still correct. Dan Grauer uses this limit implicitly. So it says here on page 366 at the bottom, it then follows that the moment we acquire 10 to the 5th gene loci, the overall deleterious mutation rate per generation becomes 1.0, which appears to represent an unbearably heavy genetic load. So where does 1.0 come from? That comes from Mueller's paper in 1950 originally, although he cites some more recent work in this one. Way at the bottom, there's something, I don't see, did he put it?
Can I have a quick conjecture real quick?
Yeah.
We have way less than like 10 to the 5th loci, right? So wouldn't that make the coefficient a lot lower still? Or I guess it would make the coefficient higher because there's less loci. So it would still mean that we're operating well below Mueller's limit.
Is he talking about nucleotides or loci?
It says
entire gene loci.
Yeah.
So what has happened is, no, that's a really good observation. What has happened is that in the over 50 years, it began to say, well, can we apply this to not just loci, but nucleotides? So you're very astute to say, what if we do apply it to individual nucleotides? And that's why there's this current thing about how much junk DNA there really is, and because if we start to go at the nucleotide level, then that changes things. And then that goes into whether these mutations that are changed, they may be very mild in their effect or pretty much imperceptible. What happens if they accumulate? This starts to deal with the non-coding thing. So back to your question about Mueller's limit, it goes back to this 1.0 figure. What does that really mean? Meaning that if in order to get the genome back to some level of better functionality, we can't be tolerating too many. We can't be tolerating too many of these mutations. So the fix that has been proposed then is that a large proportion, in Ono's time, it would have been maybe 98%, you could mutate it freely and it's not going to affect the organism's fitness. So
Have
that
you I was going to ask, have you seen the study, An Upper Limit on the Functional Fraction of the Human Genome by Dan Grauer?
Oh yeah,
Oh,
he
yeah.
loves Grauer.
I
Okay,
love
Sal
Grauer.
and Grauer are buddies.
What are your thoughts on that from that perspective?
Don't get him
I
started.
think he's actually. I think his line of reasoning. First off, he's actually implicitly using the math that I used to derive Mueller's limit, and it can be derived from the Poisson distribution. And I'm the one who prepared the slides for Dr. Sanford in his talk. It's in the NIH. I said the really funny thing is Dan Grauer is just growling about all the functionality that's claimed by ENCODE, and Dr. Sanford said Grauer's right. Grauer's right. So, and it was interesting in my debate with Professor
He's not-
Cardinale.
Not right in the way that Sanford wants him to be right.
Fair enough. But Professor Cardinale said, and this would be worth clarifying, he said, yeah, if more than 11%, if it starts to get about 80% functionality, that would be problematic. And it's like, well, to be fair, it's like, what do you mean by that? Does that mean, are you basically saying what Dan Grauer is saying? If there is that much utility to 80% of the genome, then evolution can't be true. So I want to be fair to Professor Cardinale and give him a chance to clarify what he meant. He said, yeah, if 80% is functional, that'd be problematic. So,
It would be. But when you look at what portion of the genome can sustain mutations without killing the organism, there's quite a bit of it. And Cardinale he explained it really well about this equilibrium and how if you cross over that line, you cross over those mutations that are going to be affecting non-conserved areas, you're going to kill the organism. Mostly you're going to kill the embryo. A lot of embryos never quite make it to a pregnancy, nobody even knows that they were pregnant because there was some mutation that I mean, it's the genetic entropy just doesn't work.
So,
if it did work, okay, if 80% were completely functional and genetic entropy was as Sanford put it, we would not survive past 1 month old. Our cells dividing and the amount of mutations that happen in the soma line would kill us. Maybe we'd make 6 months, but then toddlers would have to mate, and nobody wants that. Right?
all right, Mike.
Okay. I had to throw
we're
that.
going to be
I had
trying
to
to
throw
be
that
family
in.
friendly on this. Otherwise, I'm going to have to do a lot of editing on our.
Oh, you can do a little editing on it. You're going to have to, because I think I say some words, but I'm sorry. Oh, this is not a family friendly site. It's, I mean,
no, you raise a very good. I hope, but before addressing that point, I wanted to make sure that at least I got Walking Fishes. What was this about Mueller's limit?
okay.
Okay, yeah.
That's kind of a little bit of the history. So our load of mutations, he derives it differently. He goes through like 60 pages of the derivation. It can be done very simply in maybe 2 pages. Now that we have kind of the more modern, like a lot of things, we know how to do things more efficiently. So I can derive that. So there's this thing where you asked me about Grauer. Grauer said, well, if ENCODE's right, every female needs to make 10 to the 35th offspring.
Yeah.
So that one offspring, at least 10 to the 35th, at least, so that there'll be one offspring without a bad mutation. And he said, that's bonkers. And then Dr. Sanford quoted him. He said, yeah, I agree. Dr. Grauer's right. It is bonkers.
Yeah,
but if
you
we
walked
use,
right into that.
yeah. So if we use Grauer's own figures of about 10% functionality, well, the females only need 44,000 offspring per female, and so this derives directly from the Poisson
Are
distribution.
you sure about that?
Yeah.
That if 12%, we need 44,000 offspring. I think his math must have been wrong.
Why don't I show the math? Because that's how. In fact, I quoted. Yeah, I blazed through this so quickly during my talk, but maybe that's worth another lecture.
Yeah.
Just from the pure math, because even Iyer Walker, Keatley, Nachman, Kroll, so many others will say, okay, if U, which is the mutation rate per individual per generation, if it's even 3, the female needs to have 40 offspring, and if U is equal to 1, then that's the limit. U equal to 1, that then each female can have about 3 kids will be okay, because E to the first power is like 3.26. So let's say 4 kids. That's tolerable. So there've been propositions like soft selection and synergistic epistasis as a solution, but the preferred solution by people like Professor Cardinal and Dan Grauer is to say the genome's junk. So there are at least three possible suggested solutions. So maybe I'll make a lecture on Mueller's limit, just because there's been enough questions about this.
Yeah, please do. I'm actually really curious about what you mean by that.
Okay, sure. So this is why when Speed of Sound was accurate saying I love Grauer, because he actually uses the math I'm acquainted with, and it's actually the math that is part of the genetic entropy argument.
So which paper by Grauer is it? Well, I can find that one.
I can
Rubbish
look it real quick.
DNA on archive. Rubbish DNA on archive.
Okay, I don't have that for.
I have this paper right there. I put that. I didn't put it in the live chat, but it's an upper limit on the functional fraction of the human genome. And I was confused because it does say it has in scenarios where 10% of the genome is functional, and the deleterious mutation rate is 4.0 times 10 to the negative 10th. That's a very survivable range, right? It doesn't get like super absurd with thousands of children and stuff until you have about a factor of 10 higher, or not a factor of 10, but like a factor higher of a deleterious mutation rate.
So maybe I'll make a video on that and we can talk about it.
Yeah.
Because I think even if we don't agree about the conclusions, we can say, okay, this is where we disagree. We can at least identify what the root cause. So just like today, we're able to say, really the root cause is the worldview, the engineering, medical, creationist viewpoint of what functionality means. So,
okay, yeah, that's fair.
So
okay, we're at 2 hours, so.
Okay, so maybe we'll quit soon, but I really appreciate the time. Let me just put in the chat here.
Grauer paper?
Yeah, the Grauer paper.
You putting it in private chat? Or?
I think you'll like Grauer. He reminds me of you, Mike. I like to call you Iron Mike.
Yeah. I was little Mike for most of my life, and my Uncle Mike was Big Mike, and now I'm Big Mike and Iron Mike and Old Mike and Grandpa and Uncle, and pretty amazing.
Yeah.
Being old is kind of cool. You get to do all this stuff.
Yeah.
You get to make dark jokes about toddlers. I'm the uncle that nobody wants at Thanksgiving dinner. Which I absolutely love. Okay, so Walker, you posted a paper. What was that?
That's the other one by Dan Grauer that I was talking about.
Okay, so should I put that in like real chat?
I mean,
yeah, that'd be great, because then since this is recorded, then the viewers can.
Right, you guys. Well, I'm gonna doctor the description, but this is gonna take me like an hour or two tomorrow to get all the links in here, because we've talked about a lot of papers.
Yeah.
But okay, that is the one, the Grauer paper that you're talking about, right? So, I thought you were going to
Rubbish DNA. I couldn't get the link because I have on my other computer. It wouldn't let me get the link.
Okay.
It's not the best computer, so
I will dig that up, and we'll probably have another hangout and talk about that. But
yeah, that's where he's figure 10 to the 35th, and he goes, "That's bonkers."
We're not going to get more than like 10 views of people that are this interested in going this knee deep in this stuff, but I think it's all valuable. So we talked about a lot of papers, put a lot of stuff out, but we're at 2 hours, and I have to go make dinner.
And you have another
All right.
live stream coming up pretty soon, right?
That's at 8 o'clock tonight with Dr. Cardinal.
Okay.
Or is that his last name, Cardinal Stern?
Yeah, Cardinal.
Okay, yeah.
Cardinal?
Stern, yeah. Okay.
You can ask him how the correct way to pronounce it.
Yep. Yeah. That I'm looking forward to that tonight. I kind of wanted to do this, but we will do this again, and we'll get a little deeper into some of this stuff. I'm getting into some of the mathematics in Top 10 and Camaro and Crow, but I have like 6,000 projects at the same time, so it's going to take me a while to get there. So anyway, I'm going to end this broadcast. Do you anybody have anything else to say?
No.
Okay,
Hope
we will
everyone
chat.
Great day, I guess.
Okay, we
Thanks,
will
Thanks,
chat.
Walker.
We'll chat for a bit after I end it. Okay.